Okay, this next section is a little boring just because I have to talk more than anything. So I'll try to do it, you know, quickly, and hopefully hopefully it'll all make sense. If not, you can always ask questions. I would suggest reading through this section of the book. I suggest you read all of the book all of the time, but especially this one. So this is just showing you kind of how energy flows from one form to another. So energy is not created or destroyed, it's just here and it's converted from one form to another. And this picture, I guess I should show you a little bit more of it. It's just showing how it can go from nuclear energy from the sun to radiant, which is light, and then we've got it going into our trees, which produces obviously oxygen, through photosynthesis. And then, people then breathe that air, which is also a chemical reaction. And then I guess it's showing that they're riding these bicycles. And that's going to be mechanical. That's like your potential kinetic energy, which is also creating heat through friction and just stuff like that. And so that's going to end up being converted back to radiant energy. Energy sources of today. Now these might be a little off, but for the most part, they're pretty on. So these are things that we use today. We use natural gas, we use coal, we use petroleum. These are things for like oil that make gasoline. We use a little bit of renewable energy and about 9% of nuclear energy. So our three main ones are natural gas, coal, and petroleum. So you need to know those three. Those are known as fossil fuels. And all of those things can be traced back to photosynthesis, which just shows that it went through this huge process a long time ago, and now we're using it up, but it took a long time to make. So once we use it up, we're not going to have any. Okay, so petroleum is made from oil-bearing rock, which, like I said, came from organic sediments like plants and stuff. Through pressure and bacteria and lots of time, it made into this petroleum. Natural gas, it's formed very similar, except it's at higher temperatures, and those two things are usually found together. Coal is accumulated from plants as well through pressure and temperature. It goes through this progression of peat to lignite to subbituminous. If you look at a picture, I don't know if they have that picture on our book. It doesn't look like it. But it's just different layers in our earth, and it goes through those layers over time. There are some impurities that are left that can create some pollutants. Obviously, when they burn coal and stuff, it's going to create that sulfur dioxide gas, which is just ick. And so those things are called fossil fuels. All right. We've also used moving water throughout time. Fortunately, it's renewable when it rains. It's very good for potential energy that can be converted into electrical energy through dams. You've got hydroelectric plants all over the place. That's 3% of our energy. Okay, so not a lot. Growth potential is limited because of availability of locations. We also use nuclear energy, which is based on nuclear fission of uranium and plutonium. I just watched the movie Radioactivity last night on Amazon Prime about Madame Curie, and she started out with plutonium and made radium. It was very interesting. I suggest it. But anyway, the fission or separating of those nuclear atoms can create a huge amount of energy, huge. And so we have nuclear power plants that do this. It's just very unsafe, and so that makes it controversial. Okay, so the energy that we consume, again, we are looking at natural gas, petroleum, nuclear, coal. We do not use a lot of renewable. All right, now this is the ones that I always think are really cool. Energy sources of tomorrow. These are known as alternative energies. They are like your solar, geothermal, hydrogen, fusion, things like that. So, just a little slide over energy conservation. A way of reducing additional energy is like, turn off your air when you're not there, or your lights, and that can save you money, and it can also save energy and be better for the environment and things like that. We have things that are more energy efficient, vehicles and things like that, catalytic converters in your cars. The older vehicles don't have those, and they produce a lot more pollutants and use a lot more gasoline and things like that. Okay, so going on to solar. Solar uses solar cells. Those can be used in things called power towers, which are mirrors that collect sunlight, and then they use that for steam generation. You can have passive applications of solar, which uses just like overhangs on your house, the way you position your windows, things like that can dramatically affect the amount of solar heat that's coming into your house during the summer or the winter and things like that. Then there's active applications where you actually have to use some kind of solar collector, like solar panels, which we actually just got on our house, and we're pretty pleased with them. We feel like we need a couple more, but for the most part, it's pretty amazing. So the unfortunate thing about solar is that it's expensive. So you pay a lot at first, but then it saves, quite a bit throughout time. Things that we use solar technology and wind energy with turbines. Have you ever been through like the wind farms and seen like those huge windmills? They can create quite a bit of electricity. The only thing is that wind is inconsistent based on the location, and some days it just isn't windy. And then also there was a lot of controversy on birds because they were killing some birds, and that was creating quite an uproar for some of the environmentalists. Biomass, plant materials that are formed from photosynthesis, they're burned directly or converted to other fuels. It's kind of what we do with our petroleum and things like that, but they are using some other types and our trash and stuff like that. So it's another type of alternative energy. Agriculture and industrial heating use sunlight to dry your grain, cure paint, things like that, using sun. Otherwise, that stuff can get really hot, really dangerous fast. Ocean thermal energy conversion using temperature difference between the surface and the ocean depth. I really don't know a lot about that, but that sounds pretty cool to me. Geothermal energy, this is like your volcanic activity. So this is also based on where you are. I do know that you can use geothermal energy like in Oklahoma. It's just it's not as prevalent as it is in other parts that have like volcanic activity, because they can heat their water tanks and stuff so easily with all of that underground geothermal stuff. Um, Geopressurized resources, your underground reservoirs of hot water that have natural gas that are at high temperatures. Dry steam. There's only 3 sites, I guess, of this in the United States. Hot water is going to make up most of the recoverable geothermal resources and can be circulated directly into homes, businesses, farms. So, depending on like where you are, hot springs and stuff like that, that can go back into your homes and stuff, and heating water and things like that, that takes a lot of energy. So that stuff is very useful if you're in that area. Hydrogen, this is one that I find pretty interesting because we have a lot of it. Well, kind of. We could extract a lot of it, I feel like, through water. But it is very combustible, and you have to store it correctly. So it's flammable, which is scary, right? So you don't want to have like a hydrogen powered car if it's gonna blow up on you, right? So you want everything to be working good in those situations. And that is the end of chapter 3. So I know I went through that last section pretty quickly. Like I said, I feel like you should read that section. You need to know those energy forms, and you need to know the different types of energy sources of today and tomorrow. But for the most part, that's pretty